Hey guys, we're going to explore your binomial theorem exam that I've given back to you. Hopefully you'll take a look at this after you got it back and see what you did wrong. And if you choose to do another attempt at this test, then you'll be in better shape, I think. So we're going to take a look here at number 1. Consider the expansion, 3x squared minus 1 over x to the power of 9. How many terms are there in this expansion? Well, what I'm going to do is do a little table here. We'll create a sort of an expansion chart here. So if I have what I have here, if I have a plus b to the power of 0, everybody knows that this is going to be 1. Okay, anything to the power of 0 is 1. If I have a plus b to the power of 1, this will be a plus b. If I have a plus b squared, this will be a squared plus 2ab plus b squared. If I have an exponent of 0, I have 1 term. If I have an exponent of 1, I have 2 terms. If I have an exponent of 2, I have 1, 2, 3 terms. So basically what I'm seeing from this expansion chart here is that I have 1 more term than the exponent I have. So if I have a power of 9, it stands to reason then I'll actually have, in fact, 10 terms in this expansion. And that is true, okay? Let's put a little smiley face there, something we just learned. Okie doke. Now, I'm going to go on to the next question here, find the constant term in this expansion. I'm going to go ahead and write the binomial theorem. Let's put it over here. Okay, I'm going to go ahead and write the binomial theorem. I'm going to put it right here. It's going to be a plus b to the power of n is equal to sigma, n on top, k starts at 0. We're going to have our little combination, n choose k, and this is going to be a to the power of n minus k times b to the power of k. In order to find the value of k for an expansion, I'm just going to focus on this. Everything else I ignore. Okay. For me in this particular problem though, my a value, which is the first term in my binomial, is in fact actually 3x squared. So what I'm going to basically have is 3x squared, and that's going to be raised to the power of n minus k. Well, my n value is this exponent right here, which is 9. I have no idea what k is, so I'm just going to say it's 9 minus k. This is multiplied by b to the power of k. In this case, b is this, negative 1 over x, which I'm actually going to call negative x to the power of 1. And then raise up to the power of k. And this is going to equal a constant term. A constant is a number. And the only way we can have a variable that's actually a same thing as a number is if that variable is raised to the power of 0. X to the power of 0 is in fact 1, which we know is in fact a number. So there's going to be a coefficient in front of this, some number, but I don't really care what that is, which means I don't really care about what these numbers are. If I raise this number to this power, it's just going to give me another number. I'm going to ignore the coefficients and only pay attention to the variables. This has a 2, and it's going to be multiplied by this 9 minus k. So it's 2 distributed into this. So it's going to be x to the power of 18, which is 2 times 9 minus 2k. And then we're going to multiply this by x raised to the power of negative 1 times k, which is x to the power of negative k. And this will equal my target, x to the power of 0. Now, when we multiply the same base, we're going to add these two exponents together. So if I add this to this, I'm actually going to get 18 minus 3k. And this is now going to equal the exponent here of 0. So now I'm going to say that 3k is equal to 18. And then my k value is in fact equal to 6. Because we're going to divide both sides of what here by 3. And 18 divided by 3 is 6. So what I'm going to say then is I'm actually going to use this whole part right here and actually figure out what my term is. So I have n choose k. So basically my k value, my n value is 9 and my k value is 6. And then a again is 3x squared, and that's raised to the power of 9 minus 6, which is 3. And then our b value, which is actually negative x to the power of negative 1, is raised to the power of k, which is 6. Alright, now I'm going to go to Menu, Probability, Combination, and just say 9, 6. 9, 6. That'll be 84 already. So we'll go back to the screen here, and I'm going to say that is in fact equal to 84, and then we got 3 raised to the power of 3, which is 3 times 3 times 3, which is 27. And then we got x to the power of 2 times 3, which is 6. And then we got here a negative 1 raised to the power of 6. And then we got x to the power of negative 1 times 6, which is x to the power of negative 6. So let's take a look at this. Negative 1 to the power of 6 is basically 1. We don't care about this. It's just not going to do anything. We have 84 times 27. That part is important. So let's figure out what that is really quickly. And we'll say 84 times 27, since I don't want to do that in my head. And that's 2,268. Okie doke. Okay, so this is 2,268. And then we have this times this. We're going to add these exponents, and it's actually going to give me x to the power of 0, which is actually the same thing as 1, so we're just multiplying by 1. So this is the actual entire term. This is the constant term. It's a constant term because it has no variables, so that's actually what that term is. That's the answer. No problem. Let's go on to number 2. Find the term containing x to the power of 10 in this expansion. Alright, so what we're going to do now is take our a and our b, these two terms right here, and we're going to say a is 5 and is raised to the power of n minus k. N is this number 7, so it's 7 minus k. And then our b, which is 2x squared, is raised to the power of k itself, which I don't know. This is going to equal some coefficient times the target, which is actually x to the power of 10. 5 raised to this power, whatever this power is, even though I don't know what it is just going to give me another number, so I don't care about the numbers. Remember, it's just going to affect this coefficient right here. And I actually don't care about this 2 being raised to the power of k. It's just another number. I'm just going to ignore it from now. All I'm concerned with, really, is this, x to the power of 2 raised to the power of k. So we're going to multiply this. This is going to be x to the power of 2 times k. And this is going to equal the target, x to the power of 10. This, therefore, tells me that 2k is equal to 10, and k should be, in fact, 5. Once I have that value, I can figure out my answer, because what I'm going to use is the target term, n choose k, a to the power of n minus k, times b to the power of k. Okay, this is part of the binomial theorem. We have n and k. This is going to be 7, which is my n value, and k, they tell me, is 5. So this is 7, choose 5. This a right here, again, is your first number in the binomial, which is 5. This is the power of n minus k. So it's going to be 7 minus 5, which is squared. 5 squared. B is this term right here, which is 2x squared. And it's raised to the power of k, which is again 5. So now really all I have to do is figure out what this is, and that will be the answer. Okay, so let's use the calculator to figure out what 7 choose 5 is as a combination. So we're going to go to Menu, Probability, Combination, 7, 5, enter 21. Very good. I'm going to say, all right, this is 21 times 5 squared, which is 25, times 2 to the power of 5, 2 raised to the power of 5, and then we got x to the power of 2 times 5, which is 10. So really I need to figure out is all this stuff right here. All right. Got 21 times 25 times 2 raised to the power of 5, some big number. It's going to be 16,800. Very well. All right, 16,800, and it's going to be x to the power of 10. So this is the actual answer you're looking for this question, and that's that. Moving on to this third one. Here I actually give you an expression. I'm telling you this expression is expanded, and I want to know the coefficient of the term. Well, they tell me the coefficient of the term of x cubed is this. Find the value of a. So we actually want to know this value a right here. So again, I'm going to go ahead and write the binomial theorem once more so we can keep using it. Oops. Let's make that a little prettier. This is going to be n k equals 0. And choose k, a to the power of n minus k, b to the power of k. Now what I'm actually going to do is evaluate this. I'm going to use this part right here. Okay. But I have no idea, again, what k is. So I'm going to use this actually to start with. I'm going to say a is in fact 2, because that's this number right here, 2, the a value. And this is going to be plus b. Well, 2 to the raised to the power of n minus k first, which is 10 minus k. I don't know what k is. And b, which is this part, ax. And this is raised to the power of k itself. And this will equal the coefficient here. Remember, we have n and k. This is going to be 10. Choose k. So we should put this in front of this part right here. And this is going to equal this number. And then this. That's what they're telling me, basically. This is the coefficient of this term. This number is generated. Okay, this number is generated by taking care of all of these numbers. This is a number. This is a number. This part right here, a raised to the power of k, is a number. Okay. The rest of it, though, is just going to have x to the power of k, which is going to give me x cubed. This tells me right away that k is in fact 3. So this is actually 10 choose 3. Times 2 to the power of 10 minus 3, which is 7. Times a to the power of k, well, k is what? 3. Times x to the power of 3. And this is equal to this. Okay, so all I need to do is figure out what this part is and what this part is, and then divide both sides by whatever this product is. So I go to menu, probability, combinations, 10, 3, which is 120. I'm going to multiply this by 2 raised to the power of 7. And that's going to give me this number, 15,360. Okay. It stands to reason, though, I can divide both sides by x cubed, and we don't care about that. I know this right here is 15,260, a cubed, and this is now equal to this beautiful number here. Oops, that's 7. So we're going to divide both sides by this. This will cross out, and then a cubed is whatever this is. Okay. So a cubed is in fact going to equal whatever this number divided by this number is. So this is 414,720. So we'll hit Control divide. 414,720 divided by this number we just found, which is 15,360. This will give me 27. That's a great number because I happen to know something about that. I know that a cubed is now equal to 27. That means a cubed is equal to 3 cubed, because 3 cubed is in fact the same thing as 27. That means then, if we ignore these exponents, that a is in fact equal to 3. And that is your solution for this problem. Okay, now that we're on the next question here, it says, given that this binomial expansion is equal to this, what are p and q? If they are integers, find them. Okay, what we're actually going to want to do then, since it's only raised to the power of 3, is actually we're going to expand this ourselves, and we're going to use Pascal's triangle to do that. So our n equals 0 term is 1, and then we'll put 1s on either side of it. This is n equals 1. N equals 2 is 1, 1 plus 1, which is 2, and then 1 on the outside, and then we had the last row, 1, and then 1 plus 2, which is 3, and then 2 plus 1, which is 3, and then 1. So this is right here. If this second number matches our exponent, we stop. This is our coefficient array. So I'm going to come down here and say 1, 3, 3, 1. And I'm going to follow these by multiplying this term times this term for each one of them. Root 7, 3, root 7, 3, root 7, 3 root 7. And we're going to raise these, we're going to add these. The sigma in our binomial theorem tells us that. And then we're going to start with this power 3. For this 3 right here, we're going to say it's 3, and we're going to count down. 3, 2, 1, 0. For the second one, we're going to start at 0, and we're going to count up. 1, 2, 3. Now we're going to simplify this. This is raised to the power of 0, so it's 1. 3 cubed is 27. We got 3 squared, which is 9 times 3, which is again 27. And it's 27 times root 7, so it's 27 root 7. And then we got 3 times 3, which is 9. But we got 9 times root 7 cubed. Root 7 cubed is 7, so 9 times 7 is in fact 63. We got here, this is a 1 again, raised to the power of 0. And this is root 7 cubed, which is root 7 times root 7 times root 7, which is in fact 7 root 7. So now we're going to add all this. We're going to combine these numbers. We got 63 and 27. If we add those, it gives me 90. We got 27 root 7s, and we're going to add 7 more. So that's going to give me 34 root 7. If you notice, this answer right here looks a lot like this. And this right here, 90, is the same thing as my value for p. So this answer is 90. This q right here is the coefficient of root 7, of a number in front of root 7, and it's in this case 34. So this answer right here is 34. That's all you really had to do for that one. They want me to expand this. So again, every time I expand, I like to try to use Pascal's triangle. This is raised to the power of 4. So I'm going to say 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The second number matches the exponent here, so we're going to stop. This is our coefficient right here. So we're going to go ahead and write those down. We got 1, 4, 6, 4, and 1. And again, just like the previous problem, we're going to multiply these by e and 1 over e. So this is e times e to the power of negative 1. E to the power of negative 1 is the same thing as 1 over e. And then we're going to add. We're going to keep doing this, putting these two factors after that. We're going to add e to the negative 1, add e to the negative 1, add e to the negative 1. And now we're going to put our exponents down. This one, this 4, it tells me to start this at 4 and count down. 3, 2, 1, 0. And then here we're going to start this at 0, 1, 2, 3, 4. E to the power of negative 1 raised to the power of 0 is 1. This whole thing is 1. So this is basically, this whole term is just e to the power of 4. Okay? We have negative 1 times 1, which is negative 1. And then we're going to have 3 minus that 1. So it's 3 minus 1, which is squared. So this is plus 4e squared. Here we got negative 1 times 2, which is negative 2. We add that to this 2. So it's going to give me e to the power of 0, which is the same thing as 1. It's 1 times 6. So the second number is 6. Here we got negative 1 times 3, which is negative 3. We add that to this one right here, which is 1. So what is 1 minus 3? It's actually going to be negative 2. So it's going to be plus 4e to the power of negative 2. Here we got this whole thing is 1 again, raised to the power of 0. And then we're going to multiply negative 1 times 4, which is negative 4. So we're going to add e to the power of negative 4. This, technically, is your answer. It's the correct answer. However, if you wanted to write it like this, in a more correct form, so e, 6, we can get rid of the negative exponents. 4 times e to the negative 2 power is 4 over e squared. And this last term will be 1 over e to the power of 4. This technically right here is the exact same answer. So either one of those would have been correct. Alright, let's go on to the next question. They want me to express this as a sum of 3 terms. I have just found this right here in this first problem, but now they want me to do this. Okay? Now I want you to observe something. I put a negative here. The only thing different between this one and this one is this negative. So we're actually going to get the exact same answer. I can copy it here. We're going to say e to the power of negative 1 over e to the power of 4 will give me the exact same terms here. It really is what they are. Okay? This is 4e squared This is 6, this is 4e to the negative 2, and this is e to the power of negative 4. Only difference is putting a negative in here is going to cause some alternation in the signs. This one starts positive, and then it becomes negative, positive, negative, positive. So when I basically add this box right here to this, what's going to happen? Okay, what I'm going to get is I'm going to get e to the power 4 plus e to the power 4, because it tells me to add these two. And I'm going to get basically 2 e to the power 4. If I add this to this, they're going to cross out because one of them is positive and one of them is negative. So this becomes 0. I got 6 plus 6, which is in fact 12. That's your second term. And then we got this thing again, positive 4e to negative 2 and then negative 4e to negative 2. They're going to cross out and make 0 when you add them. And then there here you got, so this is going to cross out too. Here you got this plus this, the same thing twice. So it's going to be plus, it's going to be plus 2e to the power of negative 4. This is your answer for the second question. Another way you could write this, of course, is 2e to the power of negative 4, positive 4 plus 12 plus 2 over e to the power 4. This is also acceptable. So these are your two answers for this question right here. Oops. All right. Arithmetic sequences in series. All right. It says the first term is negative 2, the fourth term is 16, and the nth term is this. Find the common difference. Okay. We're going to use this formula for arithmetic sequence here. An is equal to a1 plus n minus 1 times the common difference. An is 16, they tell us, where n is 4. So an is 16, a1, which is the first term, is negative 2. If I tell you 16 is the fourth term, that means n is 4. So 4 minus 1 is in fact 3. And we're going to multiply this times the common difference. So that basically means is that 3 times d is equal to 16 plus 2, which is 18, which suggests to me that d is in fact equal to 6. So that's your first answer there. Now it wants me to find the value of n. Okay, they tell me the nth term is this, which is fantastic. So that's going to be an. This is 11998. This will equal, again, that's what we just found here. The first term is negative 2. I don't know what the n value is. That's what I'm asked to find. So this is just going to be n minus 1. And then the common difference, d, we just decided is 6. So we're solving this equation for n. We'll distribute the 6 into here. So I'm going to have negative 2 plus 6n minus 6 is equal to this. Okay, so what this in effect tells me when I solve this is that 6n is going to equal 11998 plus 8, which means 6n is going to equal 1206. And we're going to divide this by 6, both sides. So n is actually going to equal 2001. That's your n value. So that's your solution for this. All right, now we have diagrams for areas of squares, actually. It says that the area of the shaded square A is 1/4. So basically, this area right here is 1/4 right here. This area right here, as you can tell by this square and this square are the same, but this is actually 1/4 the area of this. So this area right here should be square A, which is a fourth, times a fourth, which would actually be a 16th. That's the area of square B. They're going to do this again. We're going to multiply this 1/16 by a fourth, and we're going to get the third area. So 1/16 times a fourth, because it's a fourth of that again. And that's going to be 1/64. And that'll be the area of this. Okay? So we basically are coming across a geometric sequence where we're multiplying by the same common ratio again. Find the area of square B and square C. I just told you right here that the area of square B is a 16th. The area of square C is a fourth of that, which is 1/64. So your two answers for this are 1/16 and 1/64. Okay, this is 1/16 and square C is 1/64. So that's your solution. What's the common ratio of the progression? What did I multiply this by to get 1 over 64? Or I could say R is equal to 1 over 64 divided by 1 over 16 if you want. Okay, this is going to equal 16 over 64, which is in fact equal to a fourth. R is a fourth. That's your answer. It says, what is the total area of the diagram, the area of the shaded region in diagram 2? Diagram 2 is this square plus this square. So square A plus square B. We're going to add a fourth to 1 over 16. That's all we're doing. So basically this is a skill of you know how to add fractions, which we learned in middle school, hopefully, at least. So we're going to say 1 over 4 plus 1 over 16. We need a common denominator to add. So to get this 4, the same thing as 16, I'm going to multiply the top and bottom by 4. So what this is going to give me is 4 over 16 plus 1 over 16. This answer will equal 5 over 16. That's your solution. Find the area shaded in the 8th diagram. Now keep in mind, if we have diagram 1, we have 1 shaded square. If we have diagram 2, we have 2 shaded squares. They're going to ask me for diagram 8, so we're going to have 8 shaded squares. We're going to carry on the sequence 8 times. So they want the total area of the 8th diagram. We're going to use our partial sum formula for a geometric series, and this is where r is less than, the absolute value of r is less than 1. So here's the formula for it. The sum of n is equal to a1 times 1 minus r to the power of n over 1 minus r. This is true if the absolute value of r is less than 1. In this case, our r value is a fourth, so that is in fact less than 1. So a1 is the first area, which is the area of square A. I know that to be a fourth already. So this is a fourth times 1 minus r, which is also a fourth, to the power of n. Now n is the number of squares I have, which is the 8th diagram, so there's 8 squares. And this is going to be over 1 minus a fourth, which is the r value. So we're going to figure out what this is in a calculator. Alright. So let's go ahead and do this. We're going to hit Control Divide, and then we're going to hit Control Divide again. I'm going to put 1/4. We're going to multiply this times 1 minus, open another parentheses, we're going to do Control Divide again. 1 over a fourth. Close that up. Raise that to the power of 8. This, we're going to take 1 and subtract another fraction, which is 1 over 4. This calculator tells me that this is the answer as a fraction. So you could put this answer as a fraction. This is 21,845 over 65536. Okay. So we can try that. We can say this is 21,845 over 65536. This technically I would accept as an answer. However, if you want to give this as a decimal, that's what they're asking for. They want the answer correct to 6 significant figures. So this, if you're following the instructions precisely, this is what you should have done. We're going to go ahead and make this a fraction. We're going to take this answer, hit Control Enter, and this is our answer right here. And this is already correct to 6 decimal places, so it's just going to be 4 3s and 2 8. So this is going to equal 0.1234 and then 2 8. This is technically what they're asking you for. The area, okay, the dividing, the shading process illustrated is continued indefinitely. It goes on forever. They're going to keep adding little tiny squares, smaller and smaller and smaller forever. Find the area, the total area of the shaded region. If you did this indefinitely and the r value is less than 1, it's actually going to converge on a specific value, which is what we discussed in class. Here is the summation formula for an indefinite series for a geometric progression here. So this is going to be the sum to infinity is equal to a1 over 1 minus r. This is the value it's going to converge on. a1 right here is a fourth. We already know that. And so is the r value. So it's this. So basically this becomes 1/4. 1 is the same thing as 4 over 4. If we subtract the 4 from that, we get 3/4. So this is actually going to converge on the value of a third. Okay? Keep in mind, yeah, that's your answer, but a third is actually the same thing as 0.333 forever, right? And that's actually very close to what we have here. What's happening is, even though we've only added 8 squares here, we're going to keep adding them over and over forever. But the squares keep getting smaller. So if you add smaller and smaller amounts, you're really not adding much to this. It's not getting much bigger. And it's actually going to converge if you add forever on this value, which is a third. Okay, looks like we're on the last page here. So this is number 8. Consider the sequence, x minus 3, x plus 1, 2x plus 8. When x is 5, the sequence is geometric. We'll write down the first 3 terms. So all we're going to do is take the value 5 and plug it into our x's here and figure out what they are. 5 minus 3 is 2. 5 plus 1 is 6. 2 times 5, which is 10, plus 8 is 18. That was easy. It's just 2, 6, and 18. All right, find the common ratio. That's easy. You just take one term, divide it by the one in front of it. So it's 6 divided by 2, which will equal 3. Or I could have said r is 18 divided by 6, which is also 3. So basically what you're getting out of this is that r is in fact equal to 3. All right, find the other value of x, which makes this sequence geometric. Okay, what we're seeing here then is, if we're going back to the original problem, okay, I told you if you take a term and you divide it by the one in front of it, you'll get the value r. So we're going to do that again. We're going to say, in fact, x plus 1 divided by the term in front, x minus 3, that's equal to r. But so is 2x plus 8 divided by x plus 1. And what you're actually meant to do here is cross multiply. We're going to multiply this by this top part. We're going to cross multiply and cross multiply. So what we're going to end up getting is x plus 1 squared is equal to x minus 3 times 2x plus 8. And we're going to solve this appropriately. So let's go ahead and figure this out. X plus 1 squared, okay? So that's x plus 1 times x plus 1. That's going to be x squared plus 2x plus 1. We got this times this, so this is going to equal 2x squared. And that's going to be plus 8x and minus 6x, so plus 2x. And then negative 3 times 8 will be negative 24. This is equal to this, and we just solve it for x, apparently. So if I go ahead and take away 2x from both sides, I can see this quite clearly that these are just going to go away to 0. If I take away x squared from both sides, this is going to go away, and this is going to give me 1x squared. And then now I have x squared minus 24 is equal to 1. So if I take away 1 from both sides, that means x squared minus 25 is equal to 0, which means x squared is in fact equal to 25. What do you square to get 25? There are two possible answers. It'll either equal plus or minus 5 right here. So what's the other value? Well, they already told you up here that one of the values is x is equal to 5. All right, so it stands to reason that the other value is the negative version of that. So x equals negative 5. That will be the other solution, and that's the answer for part C. For this value of x, so basically, assuming you got this answer correct, is negative 5, find the common ratio. Now we're going to go back and look at our terms. Remember, our geometric progression here started with x minus 3, x plus 1, and then 2x plus 8. That's what the original problem gave us. Now we're going to plug in negative 5 into these x's. Negative 5 minus 3 is negative 8. Negative 5 plus 1 is negative 4. And negative 5 times 2 is negative 10 plus 8, which will be negative 2. To find the common ratio, we'll just take this term and divide it by the one in front of it. So r is going to equal negative 4 over negative 8. This is actually going to equal a positive 1/2. That's your common ratio for this progression. What's the sum of this infinite sequence? Again, the infinite sum formula, so long as that r value is less than 1, and it is going to equal a1 over 1 minus r. a1 is the first term, which is negative 8. This is going to be 1 minus r, which is a half. So it's going to be negative 8, and this is going to be 2 over 2, which is the same thing as 1 minus a half, which is going to give me 1/2. So this answer is actually going to equal negative 16. That's what this answer is. And that's your final question. So this is the end of the test. I hope you looked over this carefully, and if you end up taking this test again, you'll be prepared, I hope. All right, I appreciate it.